Good afternoon and welcome to today's T&D World webinar titled Where to Start with Private Cellular Networks, sponsored by Sierra Wireless, a SimTech company. I'm Nikki Chandler, Executive Editor of T&D World with Endeavor Business Media. To begin, let me explain how you can participate in today's presentation. First, if you have any technical difficulties during the session, please submit to the questions window and our technical experts will help you out. We do recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the submit button. Also, please be aware that today's session is being recorded and will be available on the T&D World website within the next 24 hours. You'll be notified by email when that archive is available. Now, I would like to introduce our speakers for today's discussion. Grant Kyle is the Director of Partnerships with Sierra Wireless. Vikram Prasad is the Head of Program and Client Solutions at Amdocs. And David Manuel is the Senior Product Manager at Sierra Wireless. Welcome, Grant. Please go ahead.
Well, hello and greetings, everyone, and thank you so much for spending time with us today. Before we jump in, we'd like to give a quick overview of Sierra Wireless and Amdocs industry pedigree. Sierra Wireless has 25 years of module and IoT experience with 166 million devices shipped worldwide into 160 plus countries. We have over 600 partner networks supported globally, 200 patents in wireless technology, and 75 million invested annually in R&D with deployment teams on 3 continents. Vikram, if you could be so kind and give us a background on Amdocs, sir.
Thank you, Grant. Hello, everyone. Thanks for this opportunity, Sierra Wireless. Amdocs is a $4.5 billion company. We are headquartered in St. Louis, Missouri. We are specializing in offering a wide range of solutions, including customer experience management, revenue management, digital transformation. And from the division that I come from, that I represent, we're actually actively engaged in network deployment and operations. We are 31,000 employees and counting across the globe, with global delivery centers and boots on the ground supporting our customers 24/7.
Vikram, that's impressive. Thank you, sir, for your overview. So why consider a private network? And more importantly, why are we seeing private networks gain traction and build momentum globally within government and large enterprise organizations? Let's talk through this at a high level. Security is top of mind from business and mission-critical infrastructure. Threat profiles include, but are not limited to, foreign and domestic bad actors, ransomware attacks, random bugs and viruses circulating on commercial networks. All these threats can lead to crippling disruptions within your infrastructure. Networks using private spectrum are inherently secure by design, closed to the public, and accessible only to your enterprise. These networks are SIM-based authentication, meaning that the SIM and IMEI must match for the core to allow the device in the network. Reliability is a valid and lingering concern. Reliance on third-party connectivity providers adds risks, variables to business efficiency. Deploying a private network resolves third-party connectivity dependence, and it gives complete ownership of network performance and reliability. Quality is inherent to private networks as they maximize the efficiency and orchestration of your LAN or local area network, as well as giving you full ownership of wide area network. They resolve challenges including quality of service, latency, and congestion. Coverage, or signal propagation, is one of the most prevalent challenges we encounter when we talk to enterprise customers needing business and mission-critical communications. Again, private networks resolve these challenges with the ability to architect and design network coverage, indoor or outdoor, and solve challenging applications such as secure facilities in remote locations, underground mining, offshore oil rigs, remote power generation facilities, pipelines, robotics, automated assembly lines, smart warehouses, and of course, emerging AI applications. And flexibility means that the private network can be designed to maximize various applications. The network can scale to the needs of your enterprise, and as your enterprise adds more application layers and complexity to the architecture, private networks can grow with your business needs. Your organization has control of your network capabilities, scalability, multi-spectrum deployments, and CapEx over APEX. We call this slide the hockey stick. From the early days of the first CBRS LTE deployments, the industry has quickly evolved to high-performing private 5G networks. Looking at the projections from Counterpoint Research, we can see that private networks are here to stay and are growing rapidly on a global scale. By 2030, the adoption of private networks will grow to the tune of $21.8 billion. Complexity is the barrier to entry. With the massive benefits a private network can provide to an enterprise or government organization, why has there not been faster mass adoption of this technology? Private networks are perceived as challenging to design, challenging to deploy, and manage. Complexity seems to be the barrier of entry. Private networks require expertise and services that not all enterprises have on staff, and not all system integrators are readily equipped to offer. Let's go over some basic private network architecture. Let's take a look at some very basic architecture and review some hardware components to level set the conversation and the acronyms. On the left side of the slide, you will see some familiar IoT. Tablets, phones, and laptops attached to Wi-Fi. We also see robotics attached via Ethernet. When you see the Ethernet connection, think embedded OEM robotics applications, for instance. Traditional fixed legacy machinery is now able to cut the cable and modernize using router and private spectrum for connectivity. Example would be a modular robotics assembly line. And of course, LoRa sensors are also a valuable and viable source of collecting data and should be considered in your edge architecture. In the center of your slide, you'll see the router. We take a deeper dive into the Sierra private networking routing solutions later in this presentation. The router supports the global private network spectrums and is the bridge between your local area network and your wide area network. To the right of the router, we see the RAN, or radio access network. RAN is a cellular radio, much like commercial cell towers we see dotting the ridge lines of our communities. However, these towers broadcast private spectrum. RAN can broadcast LTE, 5G, or other private spectrum like 900 megahertz. Private network RAN can be deployed indoors or outdoors. Another term you might hear is an E-Node B for LTE RAN or a G-Node B for 5G RAN. And last but not least, is the core, or aka EPC, Evolved Packet Core for LTE, or 5GC for 5G applications. The core can be deployed in several variations. It can be cloud-based, it can be a hybrid cloud, or it can be on-prem. The core is the brains of the network. And the other component to the architecture in North America is the SAS, which is a FCC-certified spectrum access system. The SAS essentially regulates access to the spectrum based on the type of user. Let's talk about the 5 steps to deploying a private network. As we discussed previously, complexity is the biggest barrier to entry that we are seeing. This really boils down to not knowing where to start. And we've distilled our knowledge into 5 key steps for considerations when you successfully deploy a private network. Pathway to POC. When considering a private network, we generally start with a POC, or a proof of concept. The proof of concept enables you to verify that your network architecture is the correct solution for your use case. I will give some examples of use cases after we briefly discuss this concept. Let's follow the pathway to POC, which is the first steps in simplifying the complexity of private network deployments. At a high level, these relevant milestones on the pathway to proof of concepts will turn into cornerstones of the design, architecture, deployment, and operation. So clearly define your use case and your why, determine your network requirements, look at your network design considerations, choose the correct endpoints to support your edge, and then taking those milestones from the pathway and developing a scalable proof of concept, which will be the foundation of your network. Clearly defining your use case, and I'm going to use utilities as an example. So you probably already have a sense of why you are embarking on a private network project. So let's talk about the first milestone on the pathway to POC. Clearly defining your use case for today, I'm going to use utilities for the example. When having roundtable discussions with our utility customers and solution integrators, we've identified several current challenges that private network strategy solves for utilities. Reliable coverage over wide geographic areas, secure and isolated networks which lower your network threat profile, flexible and tailored network and/or networks, and a layered spectrum strategy, meaning architecture of multiple private network spectrums in conjunction with carrier networks. These types of solutions are being applied to applications like smart metering, grid modernization, and keeping mobile field crews connected while on site and roaming, aka mobility. Vikram will now take us for a deeper dive outlining private network requirements.
Thank you, Grant. So based on the type of use case that Grant was actually mentioning earlier, we go to the next step, which is defining the network requirements. So in this, to operate the use case for the customer, certain factors play in to define an overall architecture that would realize these use cases for the end customers. So some of these actually include the first one, which is spectrum. So based on the criticality of the application, is it mission critical? Is it non-mission critical? What would be the type of spectrum the customer would need and needs to be defined? So some of these use cases that the customers actually ask for, do they need worker safety, push-to-talk, mission critical applications? Do the applications that they need to use require high bandwidth or a low latency? Or is it an IoT application which probably just needs coverage? So based on all of these type of requirements, we define if it would need a 4G or an LTE kind of a spectrum or a 5G specific spectrum to realize such a use case. The other step is to actually ask them, do they need any coverage that is actually indoor, in building, or do they need the coverage that is actually outdoor? What is the type of throughput that they actually need from the system? So all of these requirements that actually come out of the use case and from the customer define the type of spectrum that actually needs to be addressed for the specific use case. Moving from the spectrum onto the core side, like Grant was actually talking about the 4G EPC as well as the 5G core. So so this is where the questions around does the customer need the data to be localized? So if they want no data to actually get out of their premise, it would need an on-premise core. Or are they open for a hybrid cloud model where they have separate user plane functions that's actually defined on their enterprise that actually connects back to their control core that's actually hosted on a cloud platform? The other type of questions requirements would be, do they need high availability for the use cases, which mean that they would need high redundancy, or they need redundancy like an active standby. How many SIM cards are actually needed? How many subscribers that they need to actually provision? Do they need roaming capability to seamlessly move from public to private to public? So these are some of the requirements that would actually come on the core side. Moving from the core to the backhaul and security, which is also quite important from a customer perspective, is what type of backhaul do they currently have? Is this an ISP connection? Is it a DIA? Do they have microwave links? What type of circuit is it? Is it a 1 gig circuit? Is it a 10 gig circuit? For the type of use case that they're actually trying to deploy? Do they need to have access outside their premise out to the internet? Do they need any policy or rules that needs to be implemented on their firewalls for certain applications? So these are requirements that actually come from a backhaul and security perspective. And then finally, it's the end devices or the endpoints. What are the type of devices that are actually needed? Are these just modems, routers, or are these actually powering smart metering devices? Are these fixed devices, mobile devices? Are these used to be, do they need to be, cellular as a backhaul for Wi-Fi connectivity? Are these end devices going to be cameras or sensors? So these are some of the requirements that we actually take into consideration before moving into the next phase, which is actually designing the network. So based on the requirements that we actually gathered from the first step, which is the use case, and then moving on to what I actually explained before in terms of like the network requirements. So the next step is to actually design the network that actually meets the requirements from the customer. So this typically includes radio propagation design, a simulation of how the coverage or the capacity would actually look by simulating certain radio conditions, simulating how the environment would actually look like, fine-tuning and designing to optimize the coverage and capacity of the antenna radio placements, and then come down to a bill of quantity for the customer. Once that is actually done, we move into the next phase, which is actually the architecture. So we actually provide a high-level design, a low-level design, showing how this private network actually integrates into the customer environment. So this actually includes any type of like IP planning, endpoints, showing how the traffic actually flows from the devices out to the radio core and out to the internet. So typically what the design and the architect phase is a 2 to 3 week effort. It's a very small amount of effort that actually goes in, provided the customer actually gives the feedback on the use case and the network requirements. Once the design and architecture is actually done, the last step is to actually deploy and operate. This actually includes procuring the devices, procuring the hardware, software, installing the radios, racking and stacking of the core network equipments, the end-to-end integration all the way from devices to the radio core, connecting the devices, testing, turn up, and then going into the next phase, which is the NOC operations and monitoring. So in all of these, Amdocs proactively monitors the network and becomes the single point of contact for any issues that may arise for the customer. We actually provide monitoring from our single pane of glass tool, which actually pulls in KPIs across the different private network, the private network devices or the radio or the core, and actually gives a simple, powerful, easy to use dashboard to show how the how the KPIs are actually performing for the specific customer. We actually provide flexible support models for the customer to pick and choose from, be it 5x8 or be it 24/7 type of like monitoring. So I would actually pass this on to Dave. So Dave, can you actually take us into the next one, which is choosing the right equipment that supports mission and business critical enterprises on private network spectrum?
Thanks, Grant. Thanks, Vikram. My name is David Manuel, and I'm a product manager here at Sierra Wireless, working on the router and gateway side. I'll launch in here. As any private network operator knows, a critical piece of all private networks is the choice of the endpoints, the CPE, the customer premise equipment. And in the Sierra's vernacular, that's the routers and gateways. It's the routers and gateways that connect your assets and your private network to each other. Key considerations in choosing routers and gateways are, choosing a rugged design. For any router you choose, make sure you choose a router that is engineered to operate in harsh environments for years. Outdoor and vehicle installations means extreme temperatures, high vibration, possibly wet and damp locations. Our router engineering is based on decades of in-house experience in designing rugged and high-performance routers. Performance as a consideration. Speeds and feeds are always a consideration for performance and longevity. We are a trusted Qualcomm partner, and we work lockstep with Qualcomm's chipset roadmap to deliver state-of-the-art uplink and downlink performance. Security. In this day and age of industrial espionage and other bad actors, all of your private network and router decisions must consider security. Sierra is a North American-based supplier to first responders and critical infrastructure operators, where we deliver robust end-to-end security. Part of our overall company security posture is working with MITRE as an authorized Common Vulnerabilities and Exposure CVE numbering authority. This means we are a trusted partner in the cybersecurity ecosystem. Specifically, our routers are engineered and operate on the principle of root of trust. Our security starts with the Qualcomm chipset security key, and through our router's secure boot process, keys are exchanged and our router management system, providing end-to-end encrypted security. Band support is an important consideration as your use cases may dictate the need of a mix of LTE, 5G, non-standalone, and standalone 5G networks, supporting the full cellular band range somewhere between 600 megahertz and 6 gigahertz. Our Airlink router portfolio supports the full range of bands. Router management. Remote management is table stakes in the industry. Many router manufacturers provide the ability to deliver security and feature updates remotely and over the air. Our router management system is a feature-rich and integrates into Amdocs Network Operations Center, the NOC, in a single pane of glass. Dual radio support. Dual radio router solutions are a consideration where redundancy and fallback capability is needed. Our high-end routers are expandable and are dual radio capable, meaning they can operate on 2 cellular networks at the same time, providing redundancy. Router power consumption is an important consideration in low-power industrial applications such as solar installations and battery-powered applications. There are use cases where power consumption is extremely important. We are an industry leader in low-power solutions. Back to you, Vikram.
Thank you, Dave. So how do we actually get the customer to develop a scalable proof of concept that they can actually, test, incubate, and then, build it as a private network, scale and build it as a private network? It's quite simple and straightforward. There are 3 steps. One is the test that I was actually talking. Once the test is actually done, verification, and then moving into the operation and scale. So we can actually start off with a test bed for the customer, which would actually be giving them a small footprint network in a box option. So this is a very cost-effective approach that would actually help the customer to test multiple applications that they actually want to execute, multiple devices that they would actually want to connect, multiple Sierra Wireless devices, and the use case that they actually want to deploy. So this is a very small form factor network in a box. It's just like a single server. It actually comes in with the radios, pre-built. You just have to actually put in the power and then the backhaul, and it actually turns up immediately, and it actually connects to any Sierra Wireless device. It's already pre-integrated and ready to be tested. So this is something that we can actually start off with as test. So once the test is actually done, once the customer actually gets the look and feel of the private network, once they are actually starting to integrate their use cases, the second step is to actually verify, benchmark, and validate the performance. How does this look, when it needs to be scaled? And this is where, once they're actually satisfied with the performance, we need to ensure that the design and the solution architecture is actually scalable. We then move into the bill of quantities that they need if they actually want to move into that scalable operated model of deployment. And the next step is the deployment, which is the operations deployment, the installation, and this includes what I actually discussed before in the previous slide, the design, deployment, and turn-up of the private network. Then the customer can actually define the tools that need to be integrated into the customer ecosystem, and then the operations of the network, and then how they can actually integrate their operations, their current operations, into the business as usual process, which is integrating the private network operations into the current business operations that they actually perform. So this is pretty much like how we can actually develop, a small, scalable proof of concept that can actually help them test, validate, verify, and then advance towards a scalable private network for realizing their use cases. Back to you, Dave, for the Airlink purpose-built solutions.
Thanks, Vikram. In the following slides, I'll speak to how our Airlink router portfolio is purpose-built and spans the full range of use cases, everything from low power up to the high-performance dual radio use cases. Okay, our Airlink portfolio allows customers to choose from a range of use cases and features and price points, from the rugged, low power and compact routers in the lower left quadrant up through our mid-range of vehicle routers to our high-performance 5G dual radio capable routers in the upper right. Many of our routers are available with high-performance Wi-Fi 6 subsystems that supports remote and connected worker use cases. Many of our routers support CAN bus so vehicle telemetry integration, and this opens up many interesting vehicle-centric use cases. And finally, our XR80 router is available in both 5G and LTE trim and can be upgraded to 5G via a field installable 5G radio cartridge. On this slide, I'm going to summarize our band support and performance. As shown here, our low-end, mid-range, and high-end routers each support specific use cases and radio configurations and bands. All of our routers are rugged and of industrial strength with an in-service life of 10 years or more. At Sierra, we have 30+ years of experience in engineering rugged routers. We are experts in the rugged environment and in the industrial use case. All of our private network routers are engineered in-house with cast aluminum enclosures and rated for Class 1 Div 2 for explosive environments, IP64 for water and dust, tested to mil-spec 810H for thermal shock and vibe, and all of our routers are in the industrial temperature range of -40 to +70 C. As I said before, our end-to-end software stack is based on certificate-based root of trust, and that we are a trusted common vulnerabilities and exposure CVE authority. For customers needing routers with technical assistance agreement compliances, or TAA, we offer a range of routers with TAA compliance. Our multi-network routers with dual cellular radios provide full cellular redundancy and failover capabilities to keep you connected no matter what the circumstances. Grant will explain why dual radio routers are of a particular advantage in a private network. Over to you, Grant.
Yeah, thanks, Dave. I think dual router solutions provide several key functions when architecting a private network for business and mission-critical applications. The failover concept gives you the ability to stay connected for fixed wireless applications as well as for mobility. Again, the example is mobile field crews. Dual radio applications can give you an on-ramp to deploying a private network. In other words, the ability to run your network on an existing LTE or 5G carrier network today while your private network infrastructure is being built. And then once your private network infrastructure is deployed, you have redundant network failover in place. So one of the things when we talk about network redundancy, I want to introduce our global MVO and Sierra's Wireless's managed services. We talk about architecting a POC for business and mission critical applications. Redundant network connectivity is mandatory. Typically, we see failover architecture to a single carrier. Sierra Wireless has a managed connectivity solution that will help you sleep better at night. Our managed services offer multiple carrier connectivity via one SIM card. One global SIM with a portfolio of regional connectivity solutions for LPWA, 4G, 5G, LTE, IoT deployments. This allows for multiple connectivity options for your fixed or mobile IoT assets, so you can rest assured your network has resilience and flexibility to stay connected in the most extreme conditions. Dave is now going to talk to us about remote management, coverage, and heat maps.
Thanks, Grant. Sierra's secure and scalable router management platform complements and integrates into Amdoc's network operations center, so through the single pane of glass concept. Our management platform accomplishes much more than just secure firmware delivery. It also provides features that improves business continuity, troubleshooting, and support, while reducing the overall operating costs through its sophisticated diagnostic and reporting capabilities. So our our remote management system is much more than just a firmware delivery platform. On this slide, I'm going to speak to a little bit about one of our features within our network, or within our management system, sorry. This is the cellular coverage heat map. And the heat map is a great example of a must-have feature for anyone operating vehicles in a public or a private network. With coverage mapping, you can monitor your fleet of vehicles as they transition from your private network to a public network and back. And to name a few examples, you can identify coverage holes to improve your private network coverage. You can report and monitor your vehicle's location and path. With the the management system, you can also report on driver behavior characteristics. This is an example of one of the many value-add report features of our management platform. Back to you, Grant.
Thanks, Dave. As we conclude our discussion today, I'll leave you with these final thoughts. Operational simplicity can be achieved with our portfolio of world-class OEMs and the expertise of Amdocs as a global solutions integrator. Private networks offer ultimate control and reliability from core to the edge. Purpose-built solutions architected and orchestrated for maximum performance under the most extreme conditions. Thank you, everyone, for attending today, and we hope you found this content insightful. I will now hand the presentation back to you, Nikki.
Thank you so much. Great presentation, guys. Very dynamic, and we've got some interesting questions coming in, so we will jump right in. And once again, if anyone has any questions during this the remaining session, just go ahead and type them in, and we will get those answered as we can. So first up, is private 5G true 5G? SA versus an SA?
Absolutely.
Yeah.
Absolutely it is, and that's a great question. And I'll take first bite at the apple, and then I'm going to hand it over to Vikram to bring some depth to it. So yes, we have two forms of 5G on the market today. We have NSA, which is non-standalone, and we have SA, which is standalone. Typically, we see NSA applications that are a 5G radio with a LTE core, which is not true 5G. You can't offer network slicing or some of the true power of 5G. So when we talk about private network, it is a true 5G SA network. So it gives you all the functionality, the speed, the low latency, and all the promises that 5G has been, I don't know, the hype around it in the industry. Vikram, do you have anything to add to that?
You are right on the money, Grant. So it all depends upon the use case also, right? So some of the use cases, like let's say low latency applications, high bandwidth applications, can it actually be done with existing LTE? To a certain extent, yes, yeah. But then if you're looking at extremely low latency applications, and you would need a complete true 5G standalone network. So it goes back to the use case and what you actually brought up about defining your use case and then the network requirements. And based on the spectrum, we actually come down to whether it is going to be a 5G SA or a 4G EPC type of a network. But there are two different flavors that we can actually use today, like you said, 5G SA and an NSA concept. So which actually addresses pretty much most of the use cases that the customers actually need.
Thanks, Vikram. Nikki.
Yeah, great. So next one from a participant. For the test system, what cellular network will it use? 4G and or 5G? And second part, can this system also integrate with other Wi-Fi networks that might be used for less critical applications?
Yeah, I'm going to say yes to both. So we have the capability to deploy a network in a box in both LTE and private 5G applications. Again, we would probably have a discovery call with a customer and understand the use case and the problems we were trying to solve. But yes, we can overlay that and integrate it into an existing network. Wi-Fi, CBRS, or 5G as a backhaul is a very common use case. Again, I'm gonna defer to Vikram as the architect expert on this. Vikram, do you want to add some color to that comment?
You're right again. So CBRS is a easy start for the customers, depending again on the type of use case. So CBRS is a good start. So that can be used as a test spectrum. And the second, what was the second part of the question, Nikki?
Let me check. I think it moved off my screen here.
They were asking about the
ahead.
availability of 4G or 5G in that network in a box. Did we have that availability today? Could we bring that out for customer demonstration?
Yeah, we have a 5G ready solution. We have a 4G ready solution. So again, spectrum is already available. So it's really quick, fast, simple, easy to actually get this up and running for test from a test perspective.
And let me address the spectrum. So for a North America application, the FCC has set some bands aside. Primarily in North America, you're talking about band 48 for LTE applications, and in the upper end of that spectrum is N48SA, which is your 5G. However, we have seen some one-offs with N77, N78, and now some N79 applications. And so that spectrum is available to use. And we'd be more than happy to talk through that, and depending on your geographic location, designate what spectrum would be right for you, depending on the type of application and where you are geographically located.
That makes sense.
Hey, Grant, I think there was a bit of a thread in there about integrating with existing Wi-Fi as well. And I think.
Oh, yes. Integrating with the existing Wi-Fi. So, yes, integrating with what? So here's the thing. So the private network is not a competition to Wi-Fi. We actually collaborate together with the Wi-Fi. So definitely, yes. There are certain aspects. Let's say Wi-Fi is more indoor. It doesn't have the outdoor flexibility. So this is where the private network actually, has that collaborative effort with Wi-Fi. So I would say yes, for sure.
Okay, thank you. That's great. So one more here. With private enterprise revolution, do we think, will it help to generate new 5G use cases? And any examples or thoughts on that?
You know, that's a great question. And I would almost say that private 5G is leading the charge for innovation because it's such a clean network. You don't have to worry about network congestion or latency issues. It's a true 5G assay. So when we see robotics applications in warehousing or manufacturing, AI, mech, all of these type of networks are really, really leaning on private networks to leverage that type of future deployments. Vikram, you've had some pretty decent experience in architecting these for those type of applications. So you want to talk a little bit about where you think 5G is going to lead us in the future?
Yes, connectivity, like you said, Grant, is actually opening up doors for new use cases. So be it facial recognition outdoors, be it actually video monitoring for surveillance, security, and AR, VR for let's say remote troubleshooting. You don't need to send a qualified field technician outside. You can actually have someone who actually wears AR, VR glasses and actually has provides that remote network back to the technician who can actually coach the person to fix a troublesome use case or a troublesome issue or something like that. So definitely a lot of new use cases that are actually coming into place. Digital twins. So the private network actually enables a digital twin of the existing network, which actually gives the flexibility for the customer to actually, address where they need to actually, fix certain issues, where they probably would predict issues in the network. If they make some changes, what would actually happen? So all of these are use cases that are being enabled today by private 5G. And it's opening doors for customers to come and test this out and realize their use cases.
That's really interesting. Here's another, from a participant. For utility IoT field networks, CBRS, US Band 8, and Band 103 seem to be prevalent as spectrum options. Speaking of spectrum, what is your position on these options? Any pros and cons on those?
I think that every spectrum has a benefit. So when we talk about spectrum, and I'm gonna eventually turn this over to Vikram and talk about the different types of spectrum. So if you look at spectrum as a pipeline, and you look at the data that you want to move, one of the other considerations is you have to look at range. So when we talk about like band 8 or some of these other like 900 megahertz type of spectrums, we see incredible range, which definitely has an application for utilities. CBRS definitely has a play too, and we mentioned in the webinar earlier the layered spectrum approach. So there's pros and cons to everything. There's always an advantage and there's always a con. It's a double-edged sword. So again, understanding your use case and defining the problems that you want to solve, we're going to help you to identify what spectrum is going to solve that problem for you. And many times it's a multi-spectrum type of deployment where you're going to have several different spectrums in an area of operation and leveraging those different spectrums to run that IoT and gain that information from your critical infrastructure.
Anyone else, Vikram, did you want to address that?
I just wanted to add that the multi-layered spectrum option is something that that is the way to go, because again, you can actually have mission critical applications sitting and being driven by a certain band, and then you can have non-mission critical applications that's actually done by another band. So at the end of the day, a multi-layered spectrum option is something of an approach that customers need to actually undertake.
Okay, great. Thank you. So here's another one. How scalable are private cellular networks? Can they easily accommodate growth in utility needs?
100%. I think that's one of the, when we talk about flexibility and the attractiveness of a private network, you have a total ownership. So you can start off with a very small indoor deployment and eventually grow that to an outdoor campus. When I say campus, it could be something as a truck yard where your trucks are coming to be serviced and you're using it as Wi-Fi as backhaul, and ultimately rolling that out to all your SCADA and all of the different types of power grid modernizations. So these can be as big or as small as necessary. And then again, with a layered spectrum approach, they can be as complex or as simplistic as the customer needs. Remember, you control your own network. You can talk with us and we can build a massive amount of complexity and cover a huge amount of geography, or we can come up with our network in a box and we can build it for a very small footprint. Scalable is probably one of the most attractive features on a private network.
And I would just add that like geography coverage actually makes a lot of sense, because the private networks actually offer in the outdoors, they actually offer a good amount of coverage that can geographically cover a lot of miles, which if you compare that to Wi-Fi, it's a lot more. So the amount of deployment is actually you get to deploy a lesser amount of sites, but then get more amount of spectrum bandwidth and use cases that you can actually use on that network. So and today, with technologies, with bands actually evolving, radio providers, OEMs are also evolving. So there's a lot of players in the market. So scalability doesn't seem a problem at this point in time.
And no more dead spots,
yeah.
right? So when you deploy a network, you don't have to, you're not reliant again on that third party. So with our heat mapping capability and your ability to go out and model the type of geography you want to cover, we can almost guarantee that there's not going to be any gaps in your coverage, and that mission critical infrastructure is going to have connectivity even in some of the most remote locations.
Yeah, definitely important for utilities. So jumping back to the use cases, is there a use case where endpoint, i.e. temperature sensors, connect directly to the CBRS band 48 private network tower?
Yeah, we're seeing, so that's a great question, and that's probably goes to our module pedigree. So more and more of our OEMs now are talking to us and the Sierra module team about embedding our solutions into OEM technologies. So yes, we're going to see a significant rise in devices that are going to be able to connect directly to the RAN outside of the gateway. So that is on the rise. We would think by late Q3 and Q4, these emerging technologies will start to come to market. But that's a great question, and absolutely a direct RAN connection is viable.
That's great. That'd be so useful. Vikram, did you want to comment on that, or are you guys ready for me to?
No, I think Grant hit it out of the park. Yeah.
Okay, great. So here's, have you seen any good use cases for security cameras? Any benefits for this type of high bandwidth use case versus commercial cellular? And, I think you kind of addressed a little bit of this, but maybe go into more specifics on that.
Yes, so we were involved pretty heavily in a government application with a 5G use case where we were using some AI to identify bad guys via a smart camera, if you will. And these were deployed around a large sporting event. And what we found with the carrier networks is there was a tremendous amount of network congestion. There was some issues about how much it was going to cost for an unlimited plan on a 5G to move that data. We're talking about terabytes of data moving through that particular network. So private network 100% plays a factor into those type of applications where not only are you relying on that third-party application, but you have the security when we're talking about threat assessments and any kind of sensitive data that would move through that network. But yes, that is a very, very viable and applicable. We have a lot of government agencies employing private 5G for those type of deployments and applications and use cases.
And even on the band 48, the CBRS side of the house, there are places where you can actually get up to 100 megahertz of bandwidth. So these actually become really good. It becomes a really good sweet spot for spectrum for these high bandwidth video surveillance type of use cases.
Thank you. Makes sense. So here's maybe a question for David. Are Sierra Wireless devices TAA compliant?
Yes. We have a range of devices that are TAA compliant, so also known as GSA. So absolutely.
Okay, great.
They're labeled on our website as such.
Okay, thank you. How can you explain how you support multiple networks? For example, carrier and private network.
That's a great question, and I think it's going to be a uniform question across the consortium here. One, I would say right out of the gate, if you just look at the IoT, we could talk about the dual radio solution, right, Dave? So with a dual radio solution, we could provide connectivity on one radio to the commercial carrier, whether that's LTE or 5G, and that secondary radio could be the primary connection to the private network. On a multi-spectrum type of deployment, you could also do that. So you could have a private 5G network on one radio and an LTE network on the other radio. Or you could have a multiple router deployment if we're talking about like Anterix Band 8, that 900 megahertz. We could definitely architect endpoints to support that layered spectrum.
So you mentioned multi-spectrum deployment in your answer there. Could you kind of tell us a little bit about what exactly is a multi-spectrum deployment?
Sure. So what we look at, and Vikram did a really good job of positioning spectrum as being one of the keys in our pathway to POC. That's one of the first things we're going to identify as the use case for the customer, and the spectrum's really going to identify the throughput, range, and capability of the IoT that's going to be attached to that spectrum. And Vikram, why don't you just take it and run with that and explain how we would talk through that with a customer who is looking to solve a use case, and maybe use an example from your pedigree where you have multiple spectrums out in the wild.
Yes, sure. Thanks, Graham. So let's take an example of where the customer actually wants to, deploy, use cellular as a backhaul for their IoT sensors, as an example, temperature or smart metering or some of those use cases. Plus, in addition, they want to actually have video surveillance capabilities also. So in this, there's two different aspects of spectrum. One is like your 900, which is like your low band spectrum, like your Anterix as an example, and then the other one is actually a high bandwidth spectrum, which is a 3.5 CBRS. So you have so you can actually choose while designing the spectrum, while designing the radio requirement that is actually needed to address this use case, we can actually pick a radio that actually supports these two bands. And also the end device, the Sierra Wireless device that actually goes into effect, does the right Sierra Wireless device actually support these spectrum? So it actually becomes important to actually design in that perspective. What is your radio that actually supports that particular spectrum at the end use and the end use case? And also, what is the Sierra Wireless router that actually supports that particular multi-layered spectrum, which actually executes the customer requirements for both the IoT as well as the video surveillance, as an example.
And Vikram, the core, so we've partnered with some big name core manufacturers that also support this spectrum as far as the brains of the network, right? So we can have a core, again, in that single pane of glass, that management portal where you don't have to have multiple panes of glass to see all these layers out there working. It's all orchestrated and put under one management portal, very IT friendly. And then you have the tier 1 through tier 3 support. So if they do have challenges with any of these type of spectrum deployments, you're a one-stop shop as far as giving that support and architecting that solution, right?
Yes. So the core is actually going to be agnostic to the spectrum. So it doesn't matter what type of spectrum you actually use. So the core, depending on the use case again. So let's say that we actually consider a 5G standalone core. For the sake of the video surveillance, you would want to have, let's say, everything processed at the edge, which means that I would actually design for an on-premise 5G standalone core. Now, all of this, so the radio is actually there, it connects to the 5G standalone core. These actually enable the Sierra Wireless devices to execute the use case that the customer is actually is looking for. Amdocs comes into the picture, like I mentioned before, to design all of these requirements, understand the use case, design the requirements, provide the solution architecture of how it's going to fit into the ecosystem, deploy it, and of course, like you said, operate it. So the way we actually operate it is through the single pane of glass, pulling in all of the KPIs from the different components and putting a simple, easy to use KPI monitoring for the customer to actually understand where the network is, how is it performing, and of course, be that single point of contact for any type of issues there may be. So providing the level 1, level 2, level 3 troubleshooting for the customer in terms of operations, NOC monitoring, and if there's any issues with the hardware, provide the break fix and field support to actually get that taken care of.
Awesome.
Yeah, thank you. So here's one. Does Sierra Wireless offer a millimeter wave development kit?
I'll take that one. So Sierra Wireless is, we have a module division and a router division. I'm part of the router division. We use Sierra Wireless modules in our routers. The Airlink routers don't support millimeter wave, but our modules do. So there are dev kits available for the Qualcomm supported chipsets that support millimeter wave. So I'll say yes, and if you're super interested, we can get you in touch with somebody who can get you in touch with a dev kit as necessary.
Okay, great, thank you. So this is kind of going back to CBRS band 48. Who are some of the vendors offering CBRS band 48 modems? They said they're designing they're designing endpoint equipment such as transformer temperature sensors.
You know, I think that's a great question, and I think I'd table that question for our OEM team to handle. Okay. I think, in all fairness to our OEM team, I represent our IoT team. I would like to circle back with an individual that asked that, and we'd be happy to take that offline and get them in touch with our module team and present those OEM solutions, just in the fairness of the industry.
Okay, yeah, we definitely can get that, get you guys in touch after. So can you support the global deployment?
100%. And so Sierra Wireless is a global company, as is Amdocs, and that's really the beauty in this partnership is not only do we can represent a global business unit, but we have technology that supports the spectrum globally. So as I mentioned earlier, we have teams all over the world that can go out and talk to customers about the goodness of private 5G, and in Amdocs as well too. So scalability from a business aspect is not a problem. And the reason that we did this is when we talk to our larger enterprise customers in utilities, oil and gas, they have campuses and facilities on a global scale. And maybe N48 works in North America, but in Germany, we have to look at 78. So we have to have the ability to have those subject matter experts in country to come in, get the spectrum from that particular government, because each territory or each country has a little bit different rules, and we have those subject matter experts located geographically to execute on global deployments. Vikram, did you want to mention your prowess there as far as global capabilities?
No, thanks, Grant. Like I mentioned in the beginning, so we have 31,000 employees and counting. We have we have global delivery centers across. So we have India, Greece, Israel, US, Mexico, Brazil. So we are covering the globe from a global delivery center. We actually have boots on the ground in different places across the globe, staffed with network experts on the radio side, on the core side, and on the private networking side. So all we do day in, day out is solution architecturing, getting the radios, designing them, fixing, connecting them to the core, and then making sure that everything is actually up and running from a KPI monitoring, not monitoring perspective. So we support our customers today 24/7 to ensure that their SLAs are actually met and their network is actually up and running 24/7.
Yeah, and T&D World, so we're global. So speaking of international, global, David, could you tell us, are your radios certified for sale in Canada?
Sure, absolutely. So there's two levels of certification. One is at the module level. So our module team provides the module certification, so FCC and the like. So we really focus on the US market, so AT&T, Verizon, T-Mo, and both module and router certifications. And then in Canada, yes, we do certify on Bell, Telus, and Rogers. And rest of the world, EMEA, APAC, yes, as a patchwork of certifications. So it's really dependent on the particular region of interest. But yes, Canada is supported.
Okay, thanks. We do have time for one more question before we wrap up. This one says, we have a very lean organization. How do we provide support to the customer after the deployment?
Oh, that's a great question. So I'm going to let Vikram talk about that, because he has the capability of tier 1 through tier 3 support over the horizon. So do you want to dive down into that, Vikram, and explain to him your services after that deployment?
Yes, thanks, Grant. And I think it's a very good question, and this is a very important question also. So the customer is actually if it's a lean organization, this is where we actually come in. Once the deployment of the private network is actually done, we actually go into the operations phase. So the NOC operations is where we actually have tier 1, tier 2, tier 3 support. So we have a monitoring team 24/7, follow the sun, looking at the KPIs for the customers, ensuring that there's no breach. If there is any breach, we actually look at what is the root cause analysis. If it is something that needs to be passed on to a level 2, we actually have SMEs in the radio core, transport, the application side of the house, and also the IT side of the house, who actually look at the issue, fix those issues within the SLAs that are actually being signed up with the customer. And if this is an OEM issue, we actually pass it on to our level 3 team, who actually work closely with the OEMs, with the likes of Sierra Wireless, with the likes of the radio core vendors, to actually make sure that the hot fixes are actually applied, if the software bug, if it is there, that is fixed. So all of this from a level 1 to level 3 is actually taken care of by Amdocs. And this is how we can actually work with a lean organization. If the organization wants to do it themselves, it can be a build, operate, transfer. So it actually is really very customizable, flexible type of operating models that we actually undertake with our customers.
Thank you for answering that last one. I'm afraid that we have run out of time now. So for any of those questions that we didn't have time to answer, we'll be getting back to you via email. That does conclude today's presentation. So on behalf of T&D World, I'd like to thank our speakers for their presentations today, Sierra Wireless for sponsoring today's webinar, and of course, all of you for joining. Have a great rest of your day.